the heart of every heavy-duty pump, especially in the oil field, something small is doing some seriously heavy lifting. So what's behind the motion? Let's find out what's pumped and ready for heavy-duty action.
I'm Pat Courtney with JTEKT, and we're going to talk about heavy-duty needle roller bearings, also known as solid race needle roller bearing. So when we look at a solid race needle bearing or a heavy-duty needle roller bearing, we typically have three components. We got this outer race, which is made out of 52100. The rollers are made out of 52100 as well. And then you're going to have some sort of steel cage, typically a steel type cage that's in there. You'll notice that there is no inner ring with this. So again, like the drawn cup product, and again, I'm going to be referring to the drawn cup and comparing it to it throughout this presentation because it kind of acts the same way. So like the drawn cup, the caged version of the drawn cup, you can get seals with this. This particular product has a lubrication hole and a groove cut in the OD of the bearing. This would be the standard inch product. You can also get this feature on the metric product as well. So now the version I'm showing is the cage version, which is our standard version, but you can also get this with a full complement of rollers, but it's typically a special design. Now, what sizes do we make these? Well, anywhere on the inch side from a 5/8 inch bore to about a 3-inch bore. On the metric side, though, we go from 6 millimeters all the way up to 300 millimeter bore. So we make these some very big solid race product on the metric side, but not so much on the inch side. Very similar to drawn cup, we're using needle rollers, and like we said with needle rollers, what is a needle roller? It's basically an elongated cylindrical roller bearing where once the diameter or the length of the roller becomes 4 times the diameter, it becomes a needle roller. The other distinguishing feature is those needle rollers are not ground on the ends of the rollers. So these rollers are not ground on the end, so you can't put a thrust load on this product. So no thrust load, similar to a drawn cup product. Again, thin cross section, very high radial loads. What's different between this and a drawn cup, it's this solid race, which is again, machined and ground outer race versus this drawn cup, which again is not machined or ground. It's drawn into that shape and it's much thinner. So when we look at a solid race product, it tends to look and act more robust. So it's just a heavier duty type product. Okay, so again, no inner ring, but if you don't get an inner ring, so that means that the part has to ride on the shaft. So those rollers have to contact the shaft. If those rollers have to contact the shaft, right, that shaft will have to be hardened and ground just like it were a race. Okay, so it has to have that. Now, if you don't want to machine your shaft or grind your shaft and heat treat it, we have an inner ring that goes with every single solid race bearing, our catalog size. So this inner ring will actually fit right inside that solid race product, and that would go on the shaft, and that would act as your hardened and smooth surface, your ground surface. So, and in the catalog, it actually calls out what size inner ring you need for each of these different types of solid race bearings on the inch product. So, again, very similar to cylindrical roller bearings, except that they're needle rollers and not cylindrical. Again, they're not machined on the end of the outside of those rollers. The ends of those rollers are not machined or ground. So outer race is machined and ground. We already talked about that. The thicker outer race, it's obviously thicker than the drawn cup. So if we had the same bore size, the OD of this part would be bigger because we have this thicker outer race, and we're actually using thicker rollers too. So the roller diameters are also thicker as well as the race itself. Now, because it's machined and ground, and these are made in much smaller volumes, these are a lot more expensive than your drawn cup product. But because they are machined and ground, much higher precision. So if you need a more precise device that this has to go into, you're going to want to use your solid race product. So a lot of pump designs, they have to have it. They have to have more accuracy because of what the end of that shaft is doing. So you're going to use a machined product or a solid race product. Because they are machined and ground, they're more round, they can go higher speeds. So again, this product typically can go, has a higher speed rating as well. And we already talked about the accuracy. It's going to be more accurate, so it's going to be more precise. This is going to be round in the free state. So if you do take it out of the box, unlike a drawn cup, it's going to measure round all the way around. So it's going to have that same diameter. Why? Because it's machined and ground. So you grind it to that exact dimension. Again, available with inner rings if you don't have one. Some of the metric product will actually have the inner ring with it as an assembly. Unlike a cylindrical, like we said, the rollers are not ground on the ends, so it can't take any thrust load. Unlike a cylindrical, it doesn't come with an integral inner ring on the inch offering. It is available with seals, which makes it different than a cylindrical roller bearing, because a cylindrical roller bearing, you can't get seals, but this will have seals on it. Why use a heavy-duty needle roller bearing? Well, you got to have a high radial load, thin cross-section, just like a drawn cup product, but it's a heavier duty, so it's also got to have higher precision than a drawn cup. So it's got to have, those races are more precise. The race is more precise. The rollers are the same precision, but the race is more precise. So that's going to allow you to go higher speeds. And for more accurate applications, more accuracy in applications, so that shaft isn't going to move around as much, you're going to want to design in a solid race product. Lower tooling costs also for low volume specials. So if you're a design engineer and you've got a special shaft and a special housing that's going to be a weird size, if you don't want to do that in a drawn cup, because the tooling for a drawn cup is very, very expensive. But for a solid race product, there's virtually no tooling. So the tooling cost is very low for any kind of special designs that you want to have. They're available with seals. And again, they're more robust because of that thicker outer race than a drawn cup. Where are these solid race bearings used? The most common, industrial pumps for agricultural and construction equipment. So kind of like tractors, combines, the pumps that are used in those types of pieces of equipment. So again, heavy-duty type pumps are going to use this type of product. They're used in gearboxes, power takeoff units, so that thing that comes out of the tractor off the back end is going to use these. Metal bending equipment, sawmills, marine transmissions. The larger, over 300 bore size, or the 300 millimeter, the huge sizes, are going to be used in those oil field pumps. So if you've seen those pumps in the field that are pumping the oil, those are going to typically have a solid race bearing in those. So in summary, your solid race needle roller bearings, they're going to have higher precision and more robust than your drawn cup. They're obviously designed for a high radial load capacity with a very thin cross section. Again, like your drawn cup. Unlike your drawn cup, they're going to have a low tooling cost for low volume parts, which allows you to make a lot of special designs. So even though they're going to cost more regularly, more than a drawn cup, but if you need a special design, it's going to cost you a lot less.
Thank you for watching this class on solid race needle roller bearings. When space is tight but the axial load is heavy, these solid race needle bearings rise to the challenge. Strong, compact, and built to roll. Stay tuned for more bearing training from JTEKT, formerly known as KOYO.